Welcome to Pomodoro Joe for Wednesday, April 12th, 2023. Today we're doing LeetCode problem 71, Simplified Path. It's a medium problem. All right, so in this one we're given a string path, which is an absolute path. So this represents a directory path in a Unix style file system. So this path may have some of these special directories such as dot or dot dot. We want to normalize this path or reduce this path to the base path. So that means remove any of the dots or the dot dot directories. Now it might have dot dot dot, which is just part of a file name. So it's possible to have more than one or two dots. In that case, it's just treated as a normal file name. And our goal is to return the simplified canonical path. And there are a couple examples. So home, and it just returns home, looks like without the trailing slash. Okay, so it looks like the path needs to start with a single slash. All the directories are separated by a single slash, and the path does not end with a trailing slash. All right. And then our second example here, we have slash dot dot slash, which just reduces to slash. I see, because going up one level from the root directory is a no op. Okay. And then the final example, they've got double slashes between home and foo. It's reduced to a single slash, and the trailing slash is removed. All right, so let's put 25 minutes on the Pomodoro timer and we will get started. So a directory path traversal. For this, we'll probably use a stack. So a stack is a great data structure for this type of thing. We'll be pushing directories onto the stack. If we need to go back up a directory, we can pop that directory off of the stack. And if we have to stay in the same directory with the dot, we just leave the stack as it is. All right, so we'll start with a stack. Now in Python, a stack can just be implemented using an empty list. All right, now we'll go through every character in our path, and we'll keep track of the characters in some variable I'll call name here. So it's going to be an empty string to start with. So for every character in our path, now if the character is not a slash, meaning it could be a normal alphanumeric character, or it could be a dot. As long as it's not the slash, then this character is going to be part of our current name. So let's see. So if the character is not the slash character, then our name will just append our character. Otherwise, at this point we have a slash, which means that whatever our name is will define what we do here. So our name is our current directory. So if name is equal to dot, well, in that case, we don't really need to do anything. We're not going to be tracking this directory, but we're also not popping any directories. This is just saying we're in the same directory. So in the case where we have a dot, we can just ignore it. So we just reset our name. We're not going to append this onto our stack. Else, if name is equal to dot dot. Now in this case, it means that we need to go up one directory. So we can do that by popping a directory off of our stack. So our stack.pop -1. But we run into our edge case here, where we might not have a stack. If we're at the root directory already, this is a no op. So let's double check to see if we have a stack. All right, so if we have a stack, then we can pop one directory off of our stack, and then we reset our name. And then for our final case, this is still an else if we have a name. So if it's not the empty string, well, in that case, we will push this directory onto our stack. Since we're using a list, that will be an append. So we'll append the name, and then we'll set the name equal to the empty string. Okay, so this is the basics that takes care of all of our cases. If we don't have a slash, then this is just a regular directory string character, and we'll append it to our name. If we do have a slash, then we need to check what is our current directory name. If it's a dot, we can ignore it and just reset our name to nothing and move on. If it's a dot dot, we need to pop a directory off of our stack if we have one, and then reset the name. Otherwise, we'll append the name to our stack. This is a legitimate directory. So in this case, it looks like we're resetting our name in every single case. So that might be one thing we can optimize later. Now the final piece of this puzzle is what happens when we get to the end of our list. If we didn't end up with a slash at the very end, we might still have a name, which means that we have to essentially reproduce all of this logic outside of our loop. So at the very end here, if we still have a name, and if the name is a dot, well then we will reset the name. In fact, we don't need to do anything. We could just pass here because we don't really need to change the name at this point, but we'll keep this for now. So if the name is dot, we'll reset the name. If it's a double dot, then we'll pop one directory off of our stack if we have one. And if it's not either of those and we still have some name, then it becomes part of our directory structure. So we'll append it to our stack. Now, finally, we need to convert this whole thing back into a string. So we have some result here. And we'll start it as the empty string. And then we have to say for every name in our stack, well, now we have to append a slash plus that name. So the result plus equals slash plus the name. Okay, and finally we can return our result. But what happens if our stack is empty? Well, in that case, we will have an empty string for our result, which we don't want. We need to have something. So we'll have to say if result, else we'll return a slash. Okay, so this should do it. Let's just look over this really quick. We start with a stack. We have an empty string for our name. For every character in our path, if it's not a slash, then it is a legitimate directory string character. So we'll put that in the name. Otherwise, if we do have a slash, we'll check what is our current directory. If it's a dot, then we'll just reset our name to the empty string and we can move on. We don't need to do anything. If it's the double dot, then we will have to pop something off the stack. So we pop one directory off the stack to essentially go up one directory, and we reset the name. If the name is not empty at that point, then we have some legitimate directory name, and we will push that onto the stack and reset our name. Okay, once we are out of the loop, we have to do that whole thing again for our name because we might still have some directory name left in our name variable here. And finally, at the end, we convert that entire stack into a string by putting slashes in between all of the elements of the stack. And then we can return here at the end. All right, wow, let's give it a run. And we pass. Let's see how we do. We pass, but we do pretty terribly. We only get 8.7% for runtime and 28% for memory. So let's do a couple things to improve on this. All right, so the first thing we can do here. So we're actually reproducing the same logic twice, which is always a bad sign. One of the key elements of good programming practice is do not repeat yourself. It's called the dry principle. So do not repeat yourself, and here we are repeating ourselves. So how do we get around repeating ourselves here? Well, the reason why we have to repeat ourselves is because we go through our entire path, we get to the end, and we might have something left in name. Well, what if we just made sure that our last character was a slash, and that would force this set of logic to run? So we can do that pretty simply by just saying for every character in path plus a trailing slash. So we're forcing a trailing slash at the end. Now that will force us to do this set of logic, which means that we don't need to keep a separate set out here. Now we're not actually changing our path itself. We are just adding this slash to the end of the path that we're iterating over. All right, let's try this, see if this helps us. Still works. Let's see if we gain anything. All right, we'd make a little bit of a gain. So we're at 21% for runtime and 28% for memory. All right, what else can we do in here? Well, another thing we're doing is we are resetting this name every single time. What if we just reset the name once out here? And we can clear this out. Oh, but what do we do in here when we have something that we actually can't just clear this, because this will have an invalid syntax. We have an empty if statement. Well, we can do a pass, meaning if we get this condition, we'll just pass. And in fact, we can do better. We can continue. No, we can't continue because we'll have to reset the name, so we'll have to pass. Okay, let's try this. Still works. Let's see if this gains us anything. Not really, 26% for runtime. We do better in memory though, 69% for memory. Okay, so let's keep going down this path. I'm gonna jump ahead a little bit, take bigger steps each time. So down here in our result, we're just going through this result and adding slashes directly. So one thing we could do is use a function called join. Now what join will do is take all of the elements in an iterable, like our stack, and push them together into a string separated by whatever character we start our join with. So we can say result is /.join stack. So this will basically take slash and all the elements in stack and join slashes between all of those elements. So that does all of this work for us. And it should be a little bit faster. Now the one thing it won't do is our leading slash. So we actually have to do a leading slash before. All right, so that means that we don't actually need this else here because we're forcing a leading slash no matter what. Okay, so that might help. See if this gives us any gains. Ooh, that's a significant improvement. Now we're at 66% for runtime and 99% for memory. That's great memory. All right, so where else can we go from here? So in this case, if the name is a dot, we will just pass. And we need to reset our name down here. Or we can say reset the name and continue. Maybe we'll do that. If the name is a dot dot, then we will need to go up one level and reset the name. It might seem like we're going backwards here because we refactored this name out and now I'm putting it back in, but I'm doing that so I can do this continue, which might help us, give us a little bit of performance. So now we don't need this else if. We can separate these if statements. Now we have one if that says, is this a dot? If it is, then we'll just reset the name and continue. If it's a dot dot, then we'll go up one and reset the name. Otherwise, if the name is not empty, we can put something on. Now, what if it is empty? Well, we don't really need to do anything. So we could actually move that if it is empty up to here. So we can say if not name or name is equal to the dot. Then we can do all this. And then down here, we can just say this is an else. All right, let's see if this still works. Still works. Let's submit that. And now we're at 86% for runtime and 69% for memory. All right, so now I'm gonna jump way ahead and we're gonna do something. Instead of going through every character, one character at a time, we are going to use a function of Python called split. And what split will do, it will take a string and split it on a given character. So I can say elements is equal to our path.split and give it the slash character. So now our elements will be an array of all of the directory names without the split character in between. Now we just have to go through every name in our elements. So this should basically be the same thing. Now, we don't have this character anymore, so we have to get rid of this section here. And now we're just looking at the name itself. All right, let's check this out. Oh, and in fact, we don't need to do this because we're iterating through the names in our elements, so we won't have to reset the name to be an empty string. All right, that's cleaning things up quite nicely. Let's see how that goes. Still works. Let's see if this gets us any runtime gains. All right, we're at 82% for runtime and 97% for memory, so not a great gain in runtime. Went from 86 down to 82, but we made gains in our memory. Okay, let's keep reducing. Let's see if we can jump to a 90+%. So one, we can get rid of this. Two, we can actually consolidate some of these onto single lines. So this is not great programming practice. I would not do this if this were production code, but for this sort of test type code, this is okay to do. But yeah, don't do this in production. All right, so if we have a name, or if we don't have a name, or the name is dot, we'll just continue. If the name is dot dot and we have a stack, we'll pop. Otherwise, let's see, that should be it. I think I can actually reduce this, and I can reduce this. Again, don't write this kind of code in production. And that dropped us down. We're actually doing way worse. 38% for runtime and 97% for memory. Don't know why that would be so much worse. That's surprising. All right. Let's try to change some of our names here. So instead of calling this name, I'm just going to call it N. Instead of stack, I'll call this S. And instead of elements, I'll call this E. Again, this is not good production code. I would not write this in production. Okay, so we have a stack, we have some elements. Now for every node or name in our elements, if we don't have a name or the name is a dot, we'll continue. If the name is double dots, then we'll check, do we have something in our stack? If we do, then we'll pop it off the stack. Otherwise, we'll just append our name onto our stack. At the very end, we join our entire stack into a result and we return the result. All right, let's see how this goes. It still works. And we are at 90%, just barely, 90.2% for runtime and 97% for memory. So we took this from this big mess of code with duplicated logic all the way down to this tiny little, how many lines is that? I don't know, a dozen lines of code or so. So there's still things you can do to bump this up even further. One thing I could try is remove some of these spaces. There are different things you can do to try to improve on this. So for me, I'll probably leave it here. Let's see if this gets us anything, and then I'll call it a day. We are at 94% for runtime and 28% for memory. Okay, well that is it for me today. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.